Cool side. So, yeah, we are live. So, hey, hi everyone, and thank you so much for joining us today. Hi, Flo, thank you so much to you too as well to make this thing happen and joining us for today. So, hi everyone, this is Yash from Figment, and I welcome you all to today's this insightful session. And today we have Florian with us as our guest speaker for today's workshop on the secret NFTs. Flor is a builder and the person, secret manufacturer, and the Secret Heroes NFT game, which is the first secret NFT game on Secret Network, I think, on which Floor can share details and how we actually lead that particular hackathon project into a global product, which is very famous in the secret network and all around the NFT community. So that's a great thing which Floor built. So he will be talking about all this kind of stuff. Like he will also focus more on the SNIP 721 token, NFTs, and all. So that's all we are going to cover up. Right. So thank you so much again for joining in. Over to you, Floor. This is yours. Stage is yours. You can take a lead.
Thank you so much. Let me just quickly share my screen. Okay, you should see my screen now. Yeah, also welcome from my side to the workshop From Zero to Your First Secret NFT. As Josh already mentioned, my name is Florian. I am a software engineer. I am personally super interested in privacy, obviously, computation and creativity, where I'm doing a PhD at the moment, and also systemic design. And my background is from games and nature-inspired computing, so neural networks, evolutionary algorithm, all that thought. If you have any questions during the workshop, feel free to put them into the Ask a Question box on the bottom. Maybe we will have some time to answer them in the end. But as we are going to do a bit of live coding, I'm not sure how we will fare with the time because those things tend to break a bit. In any case, you can reach me on Twitter, also on Discord. So I'm on the Figment Discord. I'm also on the Secret Discord. So if you have any questions afterwards, please reach out to me. I will try to answer them. Exactly. And so some of the things that I've been building on Secret Network is, as Yash already mentioned, the Secret Heroes game and also Secret Manufacture. So if you haven't tried them out, you should definitely, but that's not something for today. I assume that most of you are familiar with Secret Network, but just so that we are all on the same page, one slide about it. So Secret Network is a layer 1 blockchain solution that enables private computation and transaction, which means that you can have smart contracts on there, and the interactions with those contracts are not publicly visible to the rest of the blockchain. It's based on Tendermint SDK, so it's in this Cosmos ecosystem. And the contracts are written in Rust because of this. And then the whole thing works in a way that the nodes who are executing the contracts run in secure enclaves. And for consensus, we are only publishing the hashes of those computations. So you can have transactions and you can also have computations without your arguments and all the values ever being publicly visible to the blockchain. This is one of the building blocks for today. The other one being non-fungible tokens. Just a quick primer on this. The idea of non-fungible tokens is that they are some kind of one-of-a-kind token. So a good analogy for myself is if you compare something like the US dollar to paintings. For the US dollar, it's most often important how many of those you have and not which precise dollars you own. And for paintings, it's exactly the opposite. So you don't really tell people that you have 2 paintings, but you would rather tell them that you have, for example, the Mona Lisa and Van Gogh's Wheatfield or something. So it's important what specific token you have. And for NFTs, we have seen a lot of different use cases. So there is a huge art market where paintings or pictures are sold as NFTs. We are seeing an increase in avatars like the Bored Apes or CryptoPunks or something like this. By now, there are comics that are minted and distributed as NFTs. And then you have something for games where like a Pokemon game. So this is a Mooglet game where the cards are represented as NFTs. And what's interesting with non-fungible tokens on the Ethereum chain, for example, is that in the way they are represented, they are kind of a pointer that says that you own this token, and it points to its data points. But what that would mean is that even if I own this very rare Eurodos card, you could just look it up on the blockchain and you could have a look inside the token, because on Ethereum, everything is public by default. And you could just like grab the image, you could grab all the skill values and everything. So even if I own the token, all the content of the token is public to everyone else. Which brings some problems. For example, as an artist, if I upload my high-resolution artwork, minted as a token, and sell it to one, anyone else can come in and can download the image that I uploaded in the full resolution and can like re-upload it, mint it again. So we are seeing a lot of copy minting at the moment. And those are all problems that exist in the, let's say, classical NFT space. And now we come to the secret part. Because using Secret Network, we can have something that is pretty simple, but also pretty cool. We can have parts of this metadata private. So it can only be accessed by the owner, or it cannot be accessed by anyone. But we can encrypt it and we can hide it away from the public. And this opens up a lot of use cases. I'm not going to talk about all of them. But obviously, the art case that we just talked about. So as an artist, I could upload my image. I could encrypt the high-resolution file, and I could make sure using Secret Network that only the owner of the NFT can ever access the high-resolution file. Also, for something like auctions, you can have auctions where the current bids and who is bidding are not public by default, which is also interesting because what happens on Ethereum is quite often that people who are interested in buying an artwork, they can just look up who's already bidding on this artwork and can see how much Ethereum those person has in his or her wallet and how high they need to go to outbid them. And then use cases that I'm personally super interested in are gaming-related use cases. The obvious one being loot boxes. So you can have loot boxes where the content of the box is determined when minting the loot box, so right at the beginning, and you don't need to have some kind of centralized service that will put something inside the moment you unpack it. Because this is how it's done on Ethereum mostly. When I unpack a loot box there, I ask a central service, and this, of course, is not trust-free because people could tinker with it. And given this hidden content, I could have them inside the loot box from the beginning and then just open it up as soon as I, as an owner, want to. And then another case that we're making use of with Secret Heroes is that for many game loops, you need to have hidden information. So Secret Heroes is like a kind of a very simple trading card game where you would battle different cards based on their skills. And obviously, it wouldn't make sense if other players could see what my card has in terms of skill values, because you can make a 100% certain decision if you will win or lose this battle. So again, it's important that I can hide information from other players because I can build game loops around this. And then there are plenty of more use cases. So especially with real-life applications where you have sensitive data that you don't want to have exposed on the blockchain, you could tokenize it as well and use it for, I don't know, entry to events or to identification, KYC or something. I don't know. There are plenty of use cases, and I think we're just scratching the content of the whole block that we have here. So how does it work? From the outside, it is pretty simple. I have a user and I have a smart contract somewhere on a blockchain, and I can interact. So I can mint tokens, I can transfer tokens back and forth. I can ask for information about the token. And internally, this contract has like a list of all the NFTs that are managed by this contract, plus some additional data. And then one of those tokens internally, they do have 3 values: a name, a description, and an image field. This is kind of arbitrary, so you could have something completely different in here, but this is kind of the standard, the ERC 721 that standardized on Ethereum, and a lot of protocols are following this. And in each of those fields, you can have like any particular information. And if we leave it at this, we would be at classical NFTs. And what we get with Secret is that we have this dotted box below here. So we have kind of a second set of attributes that follows the first set. but those are fully encrypted. So whatever I put in here is not visible to anyone else except the owner of the NFT. And today we're going to take this concept and build something out of this. Due to the time, it is going to be a showcase thing to build. So it's not something that will be a product in the end, obviously. But I think it's still very cool, and it's something that gives you the building blocks to extend on this and make it into your own thing. And what we are going to build is the Secret Agent program. So obviously this is already existing on Secret, but what we're going to do is we will build NFTs of Secret Agents. And the way how we are going to do this is our agent NFT is going to consist of a name, as well as 3 visual assets. So we have a background, we have a face asset, and we have a cloth asset. And if you recall the structure from before, the way that we're going to do it is that we're going to store the name in the public name field. So everyone is able to read the name of the agents. But we're going to, as a good agent does, going to hide the identity in the encrypted files. So each of those visual assets is going to be stored in one of the encrypted fields. I did some preparation, so I have some of those visual assets done before. I uploaded them to IPFS already. So what we're actually going to store in here is the IPFS hash of those files. So we're going to talk about this in a minute when we get to this point, but this is kind of the core idea, what we're going to do. And that would be it for the introduction part. And the rest of the time, I would like to spend coding and working with you on this. There are several things that we're going to do, and a few things beforehand. The whole code is on GitHub, so it's open sourced, and it is also based on 3 single tutorials on Figment Learn. 2 of them are already online and up there, and the 3rd one will come soonish. So while you are invited to code along and try it out yourself while we're talking about this, please do not feel stressed. The whole thing will be recorded. There will be tutorials afterwards. The code is online, sorry. So when it's too fast, when it's something that you don't understand, don't feel stressed. You can always do it afterwards in your own time. Okay, so the things that we're going to do, the 3 building blocks to build any application using NFTs are we're going to get a smart contract compiled and deployed to the testnet. We're going to figure out how we can interact with our contract, and then we're going to build a simple front end to give some visual feedback to the user. And what you will need if you want to do this on your own is some kind of code editor. I will be using Visual Studio Code. And then we will need Node.js to install some packages and also run our front end locally. And you will also need Rust and a Docker toolchain to compile the secret contract. The last point is a bit tricky on Windows, but in the repository, there is also the pre-compiled contract. So if you have problems setting this up, this should not stop you. You can just skip the first part and start from the front end, basically. Diving into the project, this is kind of what we will build. Just going through it real quickly. So we will start with the backend, with the contract side. And what we have here is we have an environment file where we will store some references to our contract address. For accessing the network, we will store the access point, the access node from Data Hub. And then for the backend, we will build the SNP 721 reference, which is kind of a reference implementation of the non-fungible token contract. And then we have 2 JavaScript files. One is for deploying our contract to the network, and the other one is for creating a temporary account, like a wallet, to use in this tutorial. We will not using Kepler this time because it just adds a layer of complexity and it wouldn't fit into this 1-hour time frame. So what we will actually do is we will create a new wallet address and a private key, and we will use this from our environment file. So actually, we will start doing this. So what I will do is I will just jump into my Visual Studio Code. You see that I have the project checked out. There are some things in here already present, but for example, we don't have the contract yet. I do have those scripts here in there already, but we're going to have a look at them later. And then you see I have the contract wasm and the contract wasm zip. That is like what we will produce in the end of the tutorial in case Rust is not working for you. And then I have an env file with quite a few global variables in here, and we're going to start filling those out. And the first thing that I'm going to do is I'm going to run a node contract create account. And I forgot that I do have to install packages first. Shame on me. I'm just going to go into this and do an Npm Install, which should download some packages. Namely, what we need is the secret.js package as well as the .env to read in our environment file. And if this is done, we're going to create an account and add it to our environment file. So let's hope that it works now. That does look better. So what I get here is an address, or let's say here, I'm going to get a mnemonic. I'm sure you know, but this is like the key to your private key. So if you ever do something like me and have a public presentation and you show your mnemonic, please do never, ever use this account again, because you can all have access to this account. So I'm saving this. And one thing that we need to do, because we're going to send a few transactions, is that I have to go to a faucet, because I would like to have some testnet secret in here. And I'm just going to dump my address in here. And get a nice bunch of tokens so that we can do some action today. OK, so we have our account in here. I have also the connected to the data hub. You will need, if you do it yourself, you would need to put your API key in here. I have a second variable down here that I'm not going to show. And we're connecting to holodeck 2, which is the testnet. So these two values are what you get from Data Hub. And the rest is what we're going to generate over the course of the tutorial. OK, jumping back into the presentation. So we do have an account, and we want to start building the backend now. So what we're going to do is we're going to create a new Rust project based on the reference implementation that Bedrick wrote for the secret network. SNP 721 is like the secret network token. It is analogously to the ERC 721, which is the Ethereum equivalent. And what I want to do is this first command. I'm just going to jump back in here, go into my contract folder, and run this cargo generate. Will take a moment. And cargo is whoop. I think I need to run it in here. Right. Cargo is a package manager and build tool for Rust. So what this is doing, it is checking out the repository and creating us a new Rust project under the folder MySNP721. And you see that this folder got created here. We can go in there, and what we would do next is run cargo wasm, which is compiling the project as COSM wasm. So wasm is for WebAssembly. It's a standard to like run projects on the web. And while this is running, this will take a moment. We will have a look at kind of what is inside this. So we won't change much on the contract because it is like a complex beast, and it will like definitely be a workshop on its own to understand it fully. But I still want to give you like an idea what to look at and how to read such a contract project. They all look similar. They do have a lot of boilerplate for this Rust project, and there are most of the times 2 folders that you are going to be interested in. The first one is the schema folder, and the second one is the source folder. Now, the schema folder is especially interesting if you are a developer that is consuming a contract and not really like writing it him or herself, because it contains the JSON scheme how to talk to the contract. So if I look, for example, in the query message, I do see every query that I can send against the contract. So for example, there's a query called all tokens, and this schema describes how this query has to be formed. So it is called all tokens, and I see that that has some optional parameters and that I can provide. For example, I can have some limit, how many I would like to retrieve at maximum. It could be an integer or it could be non-existent. And this is like how you would read and understand a contract that you haven't written yourself. Same goes for handle message. It is the same for the, as query message was for the queries, handle message is for the transactions and the execution. And for example, we see here that we have a mint NFT command that could get a memo and an owner address, and that we, for example, can pass in the public metadata and the private metadata. So this is kind of how you understand how this contract works. And then the meat of the contract is within the source folder, where we do have a lot of files because it's a complex contract. But again, there are only a few that will be interesting most of the time. So we have message, which is the implementation of the communication. So what we have in here is a handle function, a handle message, sorry. And we see something similar as we saw in the schema. So the mint NFT has a few parameters that we can pass in, and this is all defined here. We have the state Rust, which defines how the contract is writing towards the blockchain and reading from it. And then you have the contract, which is the implementation of the contract itself. It's rather big, so we are looking at something around 4,500 lines of code, which we are not going to go through fully today. But what's interesting in here is, again, we have something like a handle function that is called when I do an execution on the contract. And what happens here is, for example, that I can see if I receive a mint NFT message from the contract, it will call the mint function with a lot of variables, and then I can jump to the mint function and I can have a look at the implementation of this function. I don't expect all of you to right away understand what is happening here, because you would need some understanding of Rust and most of all, a bit of understanding of CosmWasm. Just a few things to take away here is that CosmWasm is, or the Cosmos ecosystem is using an agent-based approach. So what that means is contracts do not call functions of each other straight away as you would do in object-oriented programming. Instead, they have a queue of messages, and you could call another contract by putting something into this message queue. So you can build more complex interactions by putting these messages in, and they will be handled one after another. And then it's also in the way that when one of those messages fail, it will revert the whole stack. And I think that is what is worth knowing in terms of contracts. So what we're going to do for today is we're just going to compile it as is and use it. As you may see, compiling it takes a bit of time. And what we would do after we're done with compiling, so after this CargoWasm, this is where we are right now. If this is done, what you would need to do is to optimize it for a secret network. This is done using Docker with a certain Docker image that loads this contract WASM that we just generated. It does some optimization and it outputs a contract WASM zip file. that we will unpack again, because using secret.js, we are just uploading the pure WASM file and not the zip file as you would do with the secret CLI. But because of time reasons, I just gonna cancel this, and we're gonna cheat a bit because I mentioned that I have it already prepared. So I'm just gonna put this contract WASM in here, pretending that we just generated and optimized it ourselves to save a bit of time. So assume that all of this went well. We have our contract WASM now, and the next step that we want to do is we want to upload the contract. And it is fairly simple. So if you have done any Data Hub, Figment Learn tutorial on Secret, you know the overall structure of those files. And assuming that we are connected to the network, what we want to do is we want to load the WASM file into a file buffer. Then we upload it to the network, and this gives us an upload receipt. And this is, again, something interesting in comparison to Ethereum. Though in Ethereum, uploading and initializing a contract is the same. So you upload your EVM code, and you get an instance of a new contract. And what time has shown is that people tend to not build a lot of different contracts, but instead you're uploading the same standard contracts from OpenZeppelin or something again and again and again. And this produces a lot of waste because we're uploading the same code again and again. So what the Cosm ecosystem does different is it separates uploading code to the blockchain and initializing into two steps. So what we do when we upload is we store the Cosm, the contract WASM on chain, and we get back a code ID. And this code ID can be used a number of times to instantiate this contract. So I can upload it once, and I can instantiate it again and again for different use cases. This is not something I'm going to use today. So in theory, if I give you, or if you recognize, remember my code ID, you could just instantiate the code that I uploaded. But for the sake of showing it, we're going to upload it again today. So, but upload went through, we get a code ID. And then the next thing that we need to do is we need to define how we want to initialize. If you recall, this is what we had a look at in the contract. So it expects to get a name, it expects to get a symbol. It also expects to get an entropy, which is used to initialize the random number generator. And then in our case, we would like to add something to the config, and we would like to say that ownership of our contract is public, which means that anyone can see who owns which token. It is not public by default, so the default settings are as privacy preserving as possible. But yeah, just for the sake of the tutorial, we're going to set this to public. And the last thing that we're going to do is actually instantiating the contract. So we give it the code ID. So we tell the client, please instantiate a new contract based on this source code. We give it the init message object where we configured our contract, and then we add a name. So this is just like my snip 721 and then a random number added. And then we do some error handling. And in the end, what we are interested in is the address of the contract. So jumping back in here, we have the deploy Nft script, which is exactly what you just saw, plus a bit from the boilerplate code. So what we're doing is we are getting our Data Hub node URL from the env file. We are getting our mnemonic that we saved in here. Then we are creating a cryptographic signing pen. So this is used to sign and encrypt transactions that we are sending. We are deriving our public key and our address from this, and then we are initializing this client. So this is what you see in basically every other tutorial as well on Secret Network. And then the interesting part is here we are loading the contract WASM. We had a look at this. We just need to add some information here, and I'm gonna call it secret agency. This should be the symbol. For entropy, it doesn't really matter. Random string. And then, as I mentioned, I would like to have it, the ownership to be public. And then we are instantiating the contract. So if I save this and run node contract deploy NFT, hope that everything goes well. So it is uploading the contract to the blockchain right now. Will take a few seconds, depending on my internet connection. And then if it's done, it should give us the contract address, which is something that we then will put into our environment file to use it later on. OK, didn't work, but never falter, just do it again. And if it still doesn't work, we're going to see why. 2 times the charm. So you see that we uploaded the contract, and then it gave us the console log with the contract data. And what we're interested in right now is the contract address. So we instantiated SNP 721 contract on this address. So I'm just going to copy this and put it into my environment file. Save it. And now we are already kind of done with the backend. So the next thing that we will focus on is building some kind of front end and thinking about what kind of interactions we want to have, how we will talk to this contract, and what we're going to build around this contract. This is how the whole thing will look in the end with a bit more color. So we have our secret agency. I want to have a way of recruiting new agents. So we have a text field where we can put in the name of our agent and a button. And then I would like to have a way of seeing my agents in a way that I see their visuals and the name. And we're going to do it in the form of a SvelteKit app. SvelteKit is a framework for rendering static web pages. Has a few benefits that make it a good fit for a workshop. For once, we can write components in TypeScript, which allows us to get some better IntelliSense. It is similar to React or Vue. So if you have any experience, or HTML, so if you have any experience in this, should feel quite comfortable. But again, we're not doing super complex things here. So we're just going to make use of some of SvelteKit's good properties. So jumping back into my IDE, I can close down the contract folder. I do have a few things in the front end folder already, mostly the node modules, because SvelteKit requires a few more packages and installing them takes some time. So I'm taking a shortcut here. But what I want to do is I'm in the root folder, and I'm just going to say npm init svelte into the folder front end. And this should create us a new Svelte project. It's going to ask some questions. Oh, I clicked too fast, sorry. It's going to ask the directory is now empty, but I don't care. I want to continue. We're just going to do a skeleton project. So it's the most simple way. And I would like to have TypeScript, ESLint, and Prettier. You see that we got quite a bunch of files generated in here. And what I would like to do is I would like to go into the folder. And now we would also need to add our secret.js and crypto packages as we did for the backend. And this should be relatively fast. And then we also need to run npm install to install every package that is additionally required as well. And while this is ticking in the background, we're going to have a look at the files that we are generating for the front end. So we are making use of our environment file. And besides this, we're going to have 7 more files. Starting from the bottom, this is one of the files that is already in there. It's a TypeScript file that just contains all the types for speaking to a SNP 721. So this doesn't have any actual function. It's just for me to make coding a bit easier. And we're gonna build out an index swelled. So this is kind of the landing page that you would arrive on if you open the web page. We're gonna build a swelled component for rendering a single agent. So this is gonna be responsible for loading the visual assets and putting them on top of each other and so forth. And then we're gonna build some endpoints, which is a nice feature of swelled. So we're gonna have 4 APIs, if you want so. The first one is being able to mint a token. And the way it works is if we implemented it, I can call routes/API/mint/ and I could put any name in here that I want for my agent. And this will be available in the function later on. So it will make a lot more sense when we look at it, I think. But we want to have a function for minting agents. We want to have a functions get tokens that gives us back the IDs of all the agents that we own. And we want to have a function that gives us specific information about a token with a certain ID. And then we have the viewing keys. I would like to not talk about this right now, but in a few minutes when we get there, because this is a topic on its own. And the first thing that we will do now is build out those endpoints to actually be able to interact with our contract. And the way this is, or the way we build them, is also not super complex. So this is what an extremely simple swelled endpoint would look like. And what we do is we pull in all these environmental variables that we defined in our end file. The syntax is a bit different here, but is similar as you might know it using the .env package. So we just have them available. And then what swelled expect is an exported function that is named get. You could also do post or put, so any REST parameter could work. This function will do something in the end, and then in the end, we return some kind of data. And similar to our deploy NFT, we will have some kind of boilerplate blocks that are in this route. So I do, of course, need to connect to the network. So this should be familiar. We will have basically the same logic as we had before. We will generate a cryptographic signing pen from our memotic. We will get the public key and the address from this. We will instantiate a client that points to the testnet endpoint from DataHub for our address and so forth. And then kind of the meat of the endpoint will be that we define the message that we want to send against the contract. Then we will query the contract, or if we are like changing something, we will execute the contract. And in the end, we will return our result. And having a look at the 4 routes that we're going to build, just to recap, we want to have a minting function that will take a name as a parameter and create a new agent. And I wanted to have random visual assets. So whenever I create an agent, I would like to have it randomized how he or she will look. We need the get token that gives us just a list of all the tokens that we own. We need a way to get specific informations. And then again, the viewing key thing we're going to talk about in a second. So we are up for some more live coding. I do have something called skeleton root, which is just the things that we just walked through. So I have the imports already in here. I have the block that is connecting me to the chain. And then this is the part that we're going to change. So we need to define a message, and we need to see if we would query the contract or if we would execute on the contract. And then we need to figure out what we return. So starting with the first route that is also the most complex one. So I would like to mint an agent, and I would like to pass in a name, and it is a TypeScript file. So this gives us like a folder structure, and Svelte is clever enough to parse everything in this folder. So if I go to localhost 3000/API/mint/name, it will call this function. I will just take my base stuff and put it over. And now we start to customize the whole thing. I mentioned it before, because we have this square bracket name, it means that Svelte makes this name available in parameters. So what the first thing is that I can do, I can say, declare a constant variable, and I tell Svelte, please take this params object and pull the object with a name out of it. So this is what we're gonna get out of this. And then I'm going to copy a bunch of things over in here. Those are the IPFS hashes of the files that I uploaded. So we have 4 backgrounds, we have 6 different closes for the agents, and we have 5 different eyes. And just to give you an idea, if I go to the browser, and copy one of those hashes and put it in here. So this is calling the IPF resolver that will turn this hash into an address. And if I open this, you see that I get the image, or I get an image. And if I take like, let's say this, a different hash, put it in, I do get a different image. So this just kind of works and is something that we're going to use later on. So we have our backgrounds, we have our clothes, we have our eyes, and what we want to do is we want to send a message actually. So what we need is a handle message, because what we are doing is a transaction. So I can comment this line out and comment this line in, and now we need to fill this transaction. And because I have this TypeScript definition for the contract, it's going to give me some auto-completion. So what we want to do is we want to do a mint NFT. And mint NFT requires a few things. What we want to do is we want to set the owner to the account address. So this NFT is going to be minted to my own address. And then we want to set the public metadata. And if you recall the slide that we had for a few minutes ago, I would like to have the name of the public metadata containing the name of the agent. And then I would like to add some private metadata. And in here, I will just use name, description, and cloth to store the assets that we are using for this agent. And what I need to do now is to pick one of those at random, and I'm just gonna copy something in. So what we're doing here is super simple JavaScript. We're saying take a random number, multiply it by the number of items in background. So in this case, 4. So we get something between 0 and 4. And because we have floating point numbers, we just do math floor, which converts it to an integer basically, and then we pick the nth element of backgrounds. And do the same for cloth and eye. So what this will do, it's just going to pick randomly one of those of those values, put them into the variable, and then in the message we assign the background to the name, the cloth to the description, and the eye image to image. And I think that should be it for the minting. So what we do is we have a message, we run execute on our contract that we get from the environment file and the message object. We throw an error, and now we can also like just put in here for the return. If we get here successfully, we're just gonna return ourselves the response that we're getting. And we can test this by doing, no, not yarn, npm run dev. This will start the Svelte kit server, which means that I can go to localhost 3000. It is now showing us the like standard page that comes with Svelte. And what I can do is I can do /API/min/floor. And now we must hope that everything works. And this would be like going to this endpoint. And we can also have a look here, maybe, if we have some console logs. And it should, some error, just do it again. Not sure why this is coming, but we see that it is doing something in here. And the second time we got what we expected. So this is a lot of stuff. But what it means is that we actually successfully run this transaction. So that was the first route. The others are going to be a bit easier. So do not faster. This was the most complex one. So next route, get tokens. So I would like to see all the tokens that I own. Again, copying over all the stuff from the skeleton route. This time we are going to run a query message, and what we're gonna do is gonna ask for tokens, and tokens requires us to pass in the owner that we are requesting, and I'm just gonna put account address. And this will succeed because when we initialize the contract, we said that ownership is public. So everyone, like you could query what tokens I own, I could query what tokens you own. We would not be able to look into each other's tokens, but we could see like who owns which token. So this is all we need for the query message. Query contract is also correct because we sent off a query object. And what we want to do here is, I know that the response contains an object called token list, which contains the tokens. And I'm just going to check if we have more than one token. If not, we're going to get an error. And if we have more than one token, sorry, I'm just going to return the tokens. And we can also test this by calling get tokens, and it tells me I have token with the ID 0 and 1. I have 2 because for some reason, when we get this weird error the first time, it is actually succeeding. It's just for some reason giving us an error. I don't know why, but it shows that I have 2 tokens. And if we do mint Käsekuchen, it should mint as another token. Minting takes a bit longer because we are interacting with the chain and not just reading from it. Again, weird error, no idea why, but if I call get tokens, it should now show that we have actually 3 tokens. 1, 2, 0, 1, and 2. Yeah, 0, 1, and 2. Perfect. Looking at the time, we will need to speed up a bit. So back into the PowerPoint. The next thing that we are going to build is the front end. So you see that we have a way of minting agents and getting like a list of our agents. And now we want to change this ugly default page. I'm just going to copy it over. It's fairly simple HTML with a bit of styling. But what we are doing is we have an input field where we can put in the name, and we have a button that I can click. And then we have an area where we would like to list all our agents. We need a button to set our viewing keys. We're going to see why in a second. And then we want to have a way of rendering those agents. So jumping that back in, I'm going to open the index Svelte just for good measures. This is how it looks right now. It maps one-to-one to what you see here. And I'm just going to copy over the HTML that you just saw. And we have a look at what is what in a second. I'm also going to add some CSS at the bottom. So this is purely visual stuff. And what we also need, which is going to be more interesting, I think, is that we want to have a script part at the top. So in the script part, this is where we're going to do our logic, and this is just the rendering. You see that we do have some red squiggly lines. That is for now intended. We're going to make use of a few things from Svelte. So you see that I have an input field, which is an HTML element, and I say bind yourself to a value called new agent name. So I can just create a variable called new agent name. And from now on, whenever I type in this field, it will be in this new agent name. And then what we can also do is for the minting button, you see that it expects a mint agent function. So I'm just going to copy this over. It's a function that calls our endpoint. So you have seen like how we did it ourselves by going to this URL. I can, of course, just do it from the front end as well. So this will call our minting function, and it will put in the name of the agent from the input field. And what we want to do next is we would also like to store our tokens in a list. And what you see here is when we minted a new agent, we just going to call the function that we did, which gets all the tokens and store it in this list. And do not just like wait until we mint the first time. What we can do is we can use something called onMount, which is a Svelte function that gets called when the component is like loaded the first time. So what we do when I first load the component is I get all my tokens and I store it as well in this variable. Gonna remove this button for now, and also gonna remove this for now, and instead just gonna do a div element with token in it. And what we're doing here is we're instructing Svelte to do something for each object in the token array, which is our variable. Namely, we're just going to render the token. And let's see if I refresh the page. You see that we have this nice spinner, and oh, mistake, need curly brackets. Curly brackets mean that we are not like outputting pure HTML, but we want to like look inside the variable here. So if I reload again, it will call the get tokens, and it will output the numbers of my tokens. Jumping back into this, the next thing that we want to do is create something to render those agents. Few things that we are using here. Sorry for speeding through this a bit. We can make parameters available outside of Svelte. So we're gonna like provide the ID from the inside, from the outside, and then what we want to do is we want to get the token of this particular agent. We're gonna parse the token to get the visual assets and the name, and then we're gonna render the agent by having just like 3 images stacked on top of each other. You know this URL, it's what we tested to get access to IPFS, and then the name, plus again some loader and some CSS to make it like that those images are stacked on top of each other. So going back to this, I'm going to create a folder called components, and inside I would like to create a Svelte file. I just gonna copy in what you just saw in the PowerPoint. So we have the ID that we're providing from the outside, we have the token, and we have our elements that we're going to use. And then we do have the HTML rendering the images plus the name. We're doing a check here. So as long as we don't have any visual asset, we are showing the loader. And then last thing is a bit of CSS to make it look nice. And what we need to do is to fill those values. So what I can use again is this onMount function from Svelte. So whenever I load this component, I would like to get the detailed information of this token. And then it's similar. So I await the JSON, and then I look up the fields how we did it. So the name is in public metadata name, the background is in private metadata name, and so forth. And we also need to get build the root. And this is fairly simple because it's exactly the same like it was before. So copying over the skeleton root, again, we have a parameter. So I'm just going to do ID equals params, going to pull the ID out. And our message that we are going to use is going to be a query message. And we're going to ask for the NFT dossier. So this contains all the information. And this executes a query. That's good. And what we actually want to return is the response, NFT dossier, public metadata, and private metadata. And if we test this now, we will see that something is broken. So if I query my first NFT, we did something. Oh, I forgot that we have to do an API in here. So when we get NFT back, it will show us information about the public metadata. It will not show us information about the private metadata because we have not yet set the viewing key. So very, very quick dive into viewing keys. Because the problem that we are having is that you have two types of interactions with the chain. You have transactions and you have queries. Transactions are recorded on chain and they cost secret. So we have to pay a transaction fee, and we can trust the sender of this message because for a transaction, I need to sign what I'm sending with my private key. For transaction, this also means if I would not have the private key in the applications like I do right now, but would do it with Kepler, I would need to approve every time I do a transaction. And if you think about if I'm querying my agents, I don't want the user to kind of approve something every 2 seconds. So what I can use is a query. Queries are not allowed to change anything on chain. They are not recorded on chain. They do not cost any transaction fee. This is partly true because if I do a transaction and within the transaction is a query, I need to pay, but not if I just put the query out. But I cannot trust who was sending this query. So I cannot use the address that I get for access to private metadata because as I am not signing the query, anyone could pose as myself. So the concept that Secret has is called viewing keys. It is similar to passwords. And the idea is that I do one transaction, which can be verified that it's coming from me, where I go to the contract and I tell the contract, hey, my address is this, and I would like my viewing key to be that. So the contract stores kind of address password pair in itself, encrypted in the encrypted storage. And then in the future, when I send a query, I just send the address and my viewing key as well. And then I go to the contract, I say, hey, I would like to have this private information. By the way, I am this, and my password is that. And the contract then will go to its storage, have a look if those two match, and if yes, it will return the values. So what we need to make it work, and this should be the last puzzle piece, I hope, is the set viewing key root. We don't need any parameters here. Gonna take our skeleton code. Take our skeleton code. And what we are going to send is going to be transaction. And we're gonna send set viewing key. And the key is just going to be the viewing key that we defined in our environment file. So I'm going to get here, and my viewing key is going to be just something random. And what we want to do is we don't want to query the contract, but we want to execute. So in this case, we're making sure that the contract can actually validate that it's me. And that should be it. We can just return the response again. Need to quickly restart because I changed the environment file. And I just gonna enable this button, and this button should call a function, and this function is just following the scheme of setting the viewing key. So we have a set viewing key. It's calling the API that we just generated. And then after we've done so, it's gonna refresh our tokens. And if I go here, I do have a set viewing key button, which I could click. It should have my viewing key now. And what is left to do, basically, is, I hope I'm not forgetting anything, but I think the only thing left to do is that we have to instruct, instead of rendering this, if we want to render our agent component, need to import it real quick. And what it's doing is it's taking the ID of our NFT, it's passing it to the agent, and then the agent is doing a get token for this ID, and it's parsing the data. And now we can hope that it's working. It is not yet. So we are still getting wrong viewing key error. Let me see if I have saved everything correct. So we are sending a set viewing key for a viewing key. Let's do it this way. Set viewing key. Okay, we do have some error in our viewing key file. Makes sense. Okay, try this again. Setting the viewing key. Gotta love yourself some live programming. Okay, that seems to work. So we have a viewing key set, and now we are also seeing our agent. Nice. I'm gonna refresh here. And that is what we try to achieve today. So just to check everything, I can end of workshop. I can recruit this agent. So this will trigger a minting of the token. And hopefully It should show up in a second here. Might take a bit to like finish everything. And here we are. So we have the name, and it's also generating us a new random agent. Phew. Okay, that were viewing keys. And this is kind of the end of what we're going to do. Thank you for staying over time and sticking with me. Just a few things to wrap up. So we touched quite a few things for 1 hour. So we talked about secret NFTs. We learned how to deploy, compile, create contracts. We talked about viewing keys, about front ends, difference between private and public metadata, and how to interact with like the contract that you're deploying. It is extremely simple what we did, but there are like different directions you could go. Like you could add more interactivity. The SNF 7/2021 gives you also the ability to send NFTs. You can have wrapped NFTs that are completely hidden until they are unwrapped. You could burn them. You could add a better minting logic. So for example, right now, all the visual assets are of the same rarity. So it's completely the same chance to get each of those. You could have the cooler ones being more rare and so forth. You would at some point most likely like to have a dedicated minting contract. We'll not talk about this too much right now, but at the moment only I am whitelisted to mint on my contract because I created it. And the way around this is having a minting contract. We could have like more complex use cases, like having someone giving some Discord roles based on the agents that he or she is owning. And of course, something like Kepler integration, sorting, filtering of agent would add on the UX. So that is an outlook. Again, I would like you to get in touch and keep in touch. My Twitter handle and Discord ID. Also, there are plenty of social channels for the Secret Network, the webpage, the Discord, the Telegram community, as well as Twitter. Same goes for Figment. So there's also Discord, there's also Twitter, there's also a webpage. Quite likely there might also be a Telegram community. So get in those groups, get in touch to people. If you found this interesting, get building. And last thing is a nice little thing. So I would like end this workshop with a kind of competition. So if you feel like it, I would like that you take this starter that we built during the workshop and you extend it, you add features, you, I don't know, create some gamification on top of it. And if you make something until next week, Wednesday, please tweet about it, at me, at the hashtag secretNFTs, and add a link to the GitHub repo where you did it. And from all the people who do this, who tweet at me with this, I will pick one and give out 50 secrets for one of the builders, complete at my own discretion, just to like give you some motivation on building on this. And I think we don't have any time for questions. Thank you very much for staying with me. Again, reach out on Discord or Twitter if you have any questions. Could also write in the GitHub. Really, really, really happy to get to talk to you all. All right, Yash, any closing words, or
just
are we?
Yeah, just a minute. Let me add myself to show like why it's happening like this. Okay, just I don't know, big problem, something like this. Yeah, okay, good to go. Cool. I don't know, like what's the issue over here is. Yeah, just a minute. I think I've found the option. Oh, okay, cool, right. So firstly, thank you so much, Flor, for this awesome workshop. You did really a good job on this, right? Every single attendee over here get the complete idea about what we are building over here today. So that's really a good thing. I'm really really thankful from my side, from the every single participant who joined us today, and from the whole Figment team. Thanks to you, right? And I think we have three questions, but as you mentioned, like we don't have much time to the questions. So just let me take a screenshot of these questions, right? And I will post these questions in the Figment Discord server and tag you, and you can answer these questions over there whenever you will get some time, right? I think that will work, and everyone will get their answers as well. Is it a good idea?
Yeah, I also try to answer them in the discussion, but also happy to follow up on Discord.
Yeah, great. So that will be great. I just posted the some important links. You can join us on Discord using the following links. You can check out Figment Forum. The tutorial links are already there up on in the chat section, so everyone can follow from there. If you have any queries for me, for Flor, for anyone, you can reach Discord, and we will be more than happy to help you out over there, right? So that's most of the things. Also, the most of the part which Flo covered over here, tutorials are available on the Figment Learn, so you can easily go through the every single thing which Flo covered in these tutorials, along with that guides. And also this will and might be by tomorrow it will be available on the YouTube as well, so you guys can follow with this video step by step. And thank you so much, Flo, for that 50 secret giveaway. So I was not aware with that, like you are gonna do something like that, but that's really surprise for me to come up with your own giveaway. So that's really a good thing. Thank you so much for that. So yeah, that's all for me. Anything else you would like to friends before we wrap up this workshop?
I'm super good. I've done enough talking. So again, thank you for hosting this, for bringing people into the Web3 ecosystem. And thanks for everyone stopping by, taking the time, learning, building. Really, really appreciate all of this.
Great. So stay tuned on the Figment Discord server, in the announcement channel, in the tutorial channel. More new tutorials are coming in, more new workshops are coming in. So that's how we will again sometime will join us over here, maybe again with Flo, or maybe with another developer or another builder from the Web3. So till then, stay safe and have a good day ahead. Thank you so much, guys, joining in. Bye bye. Signing off. Bye bye.